minimum or maximum value, what we want to look at is our vertex of each graph. You know, if we have, let's say, a graph looks like this, well, this graph has a minimum because it has a lowest point, which is going to be right here. Everything else is above that. So we would want to know, what is this vertex? It has an x and a y value. And the minimum is going to be the y, because we're talking, you know, up and down, minimum or maximum. If our graph is opening down, now we have a highest point, which is up here, which is we would say it has a maximum, and that maximum value, again, is going to be the y value of that point. So if we know the vertex, and then if we can determine if it's opening up or down, then we can find the minimum or maximum value. Each graph has only one or the other, not both. So let's see. First, y equals negative 4x squared plus 8x plus 2. I can see that our a value is a negative 4, so it's opening down. It's going to look like this one over here, which means it will have a maximum value. And we want to know what is the maximum value. So we have to find the vertex and figure out what the y value is. So again, in standard form like this, x equals negative b over 2a. You definitely want to have that memorized. That's going to give us the x value of our vertex. So our b value is this 8 right here. So negative 8 over 2 times our a value is the negative 4. So negative 8 over negative 8, we get back a positive 1 for the x. You know, our vertex, we have a positive 1. Now let's figure out what the y value is. I'll use a different color. So all we have to do is plug in a 1 for the x to see what we get. So y is equal to negative 4 times 1 squared plus 8 times 1 plus 2. So 1 squared is 1 times negative 4 is just a negative 4 plus 8 times 1 is 8 plus 2. So negative 4 plus 8 is 4 plus 2, which is 6. So our vertex for this graph is 1, 6, and our maximum is going to be the y value. So we would say our maximum value is equal to 6. That will be the highest value of our graph. So that one maybe seemed like kind of a lot of work, but then we can get excited when we notice that our next one is vertex form. We just want to know, okay, what is the vertex? First of all, is this going to have a maximum or minimum? We look at the number in front of the parentheses, which is a 1. We don't see it, but it's a 1 and it's positive, which means our graph is going to look like this one over here because we're opening up with our graph. So it's going to have a minimum value this time. And we want to know what is the minimum. So let's look at our vertex. Now inside the x, remember it's tricky. We change the sign. We have negative 1. And then the y value is very straightforward, whatever we see out here. So negative 1, negative 2. And it's the y value that is our minimum. So our minimum for this one is a negative 2. So now we get to our last one down here, which is intercept form. And we have to figure out what the vertex is. First we could say, hey, our a value is negative, which means it's opening down. So it's going to look like this guy over here. Opening down means it has a maximum value. We have a highest point of our graph right there. So it's going to have a max. So we just want to know, well, what is that max? So it's intercept form. What are our intercepts? Our x-intercepts, we have a negative 1, 0, and we have a negative 5, 0. If you notice, I just changed the signs of those. Now usually we're looking at a graph when we figure this out, but our axis of symmetry is going to be halfway in between these two values. So if I have a negative 1 and a negative 5, what I can do is to find the halfway point is add those two and divide by 2. So negative 1 plus negative 5, and then cut it in half to get half that value. So we have a negative 6 over 2, so a negative 3 is our axis of symmetry, which means it's also in our vertex, our x value. So now we just need the y value. So we're going to plug in and negative 3 for x. Y equals negative, parenthesis, negative 3 plus 1 times negative 3 plus 5. So negative 3 plus 1 is negative 2, negative 3, oh no, it's negative, yeah it is. And then negative 3 plus 5 is positive 2. So a negative 2 becomes positive 2 times 2, which is 4. So our y value was a 4. That's the one we care about. So our maximum value for this intercept form equation is at 4. And that's how we find the minimum and maximum value for all three forms of these quadratic